we're talking about lesson 7 in our solid geometry unit. It is cylinders and spheres. You are using tonight the 8th grade side of your formula sheet. So you need to flip it over to the other side, and this is really the first time we're going to be working on 8th grade formulas. The homework that goes with this is page 18 and 19. Now, you are on page 23 in your notes. All right, here's a sphere. Okay, it's like a basketball. Describe the cross section of a sphere. Well, if you slice a sphere, you are going to have a circle. This portion of the sphere is a radius, just like a circle, except it's from the very center, so it's kind of hanging in the middle. We could use a globe and a basketball as examples, and this is the center of the sphere. Our formula for volume of a sphere is 4/3 pi r cubed, and you are going to want to use your fraction button. Do not tell me that 4/3 is 1.3. I agree that it is 1.3 repeating, but when you enter this into your calculator, please enter a fraction 4/3, because if you round it, it's going to be off. Same thing. If you use pi, the pi button will give you a different answer than 3.14 because they are both estimates. Now, another thing that you need to point out, to enter cubed into your calculator, you're going to use the caret button. It looks like that. It is located right below the gray circle next to the x squared. And that caret tells you whatever is after it is an exponent. So any exponent would work. You could do caret 5, caret 6, whatever, but we're going to do caret 3. So find the volume of this sphere. Let me see the next one. We're going to do this one. Find the volume of the sphere. So our formula for volume is 4/3 pi r cubed. So volume is 4/3. I am going to say that our rule in this class is we're going to use the pi button. Pi button. And the radius here is 11. So when you enter that, you're going to get 5,572.5 cubic centimeters. Now, all right, I just checked this out. This one, we use 3.14. I want you to use 3.14. If you punch 3.14 in to this formula, you'll get this number. If you use the pi button, you're going to get this number. Notice they are off by a little bit, because remember, they are both estimates. So if I asked you to write this exactly, your answer would have a pi in it. But when you're doing these on a multiple choice test, you may need to try it both ways and see which one is closer. All right. A volleyball has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? Well, first thing we need to do, find the volume of the ball. So, volume, and it's going to be a sphere, 4/3 pi r cubed. So, 4/3 times 3.14 times. The radius is going to be 5. You will get, your volume is 523.3 cubic inches. Now, if we want to find out how long it's going to take us to inflate this, we can either set up a proportion or we can divide, because there's 325 cubic inches per minute. I'm going to set up a proportion. So I'm going to do cubic inches over minutes. So 325 for 1. We've got 523.3 for, we don't know, x. When you end up solving that, you get x is 1.69. volume of a hemisphere. Well, a hemisphere, it's not a semisphere. A semicircle is half a circle. A hemisphere is half a sphere. All you're going to do is adjust your formula. So volume is 1/2 times 4/3 pi r cubed. And I'm not even going to do that. You can do that. All right. A cylinder is a three-dimensional figure with two circular congruent bases connected by a curved surface. The area of the base of the cylinder tells us the number of cubic units in one layer. The height tells us how many layers there are in the cylinder. All right, now we've done cylinders earlier in this unit, and we used our 7th grade formula. Volume equals capital B times H. Well, remember, capital B is the area of the base. Our base is a circle, so the area is pi r squared. If you look on your 8th grade formula sheet, the formula for volume of a cylinder is pi r squared H. But that is exactly the same thing, because capital B is pi r squared. So I don't care which formula you use, it's the same difference. All right, let's take a look at a problem. I'm not even going to do that, because you can do these on your own. I want to do one that's more complicated. Tanya uses a cube-shaped bead to make jewelry. Each bead has a circular hole through the middle. Find the volume of each bead. So this is a more complicated problem. So we've got a bead, and we're drilling a hole down through the middle. I want the volume of the bead. Aren't I going to find the volume of the cube and subtract the volume of that cylinder that goes down through the middle? So our volume of our cube is length times width times height. And they're telling us it's a cube, so all sides are 12. 12 times 12 times 12 gives me 1,728. Minus our volume of our cylinder, pi r squared H. So pi is 3.14 times the radius. The diameter here is 2, so our radius is 1. And the height of our cylinder is going to be 12. I will end up with 37.68. And when I subtract, I will get 1,690.32 millimeters squared. All right. Last but not least, the service count is building models of storage chests like the one shown below to donate to a charity. Find the volume of the chest to the nearest 10. Well, take a look at this. Don't we have a rectangular prism on the bottom here with a half of a cylinder on top? So if I want to find the total volume, I'm going to find the volume of the rectangular prism and add half a cylinder on the volume of that. So rectangular prism, length times width times height is 30 times 25 times 50. That's a times. You get 37,500 plus volume of the cylinder is pi r squared H, but I only have half of it, so I'm going to put a half in there. So I end up with 1/2 times 3.14 times the radius of this thing. Well, that's the diameter, that's 25, so my radius is going to be 12.5 squared, and the height is the distance between the two bases, that would be 50. You will get 12,265.6, and when you add those, 49,765.6 cubic